So now let's look at the relation x equals y squared. What do you think that might look like? Simon's parabola, like that then. Oh, other side, why the other side? Positive, very good. So I would expect it to look like this, correct? Do we have something like that? Everyone else like that? Why did I write sketch the relation and not sketch the function? Not a function. Why is it not a function? Two y values for x values. If I was commenting on the range of the domain, what is the range for this function?
Y is a real number.
Y is a real number. Y can be anything. What's the domain?
X is greater than
X is greater than 0. Or equal to 0. Very good. Cool. So, I was going to get a bit more on that, but I think it's probably most pertinent that we look at functions. So we're going to look at square root functions. I want us to look at our understanding of x equals y squared and rearrange that to make y the subject. So I just want to have y by itself. So how do I remove a squared? Square root. So I should have y equals square root x. So what do we think the general shape of that function looks like? What do you reckon? So just the same thing but only positive, correct? That is a function because there's only one y value. What do we call this point on a parabola? What do we call it? If the parabola was there, would we still call it the origin? What do we call that? Vertex, very good. So what do you think we call the point where that starts? Vertex. Cool, so that is called, that point where it starts is called the vertex. Awesome. Pretty happy with that? We're going to look at, much like we looked at all the other functions, we're going to look at our square root functions now. It's a function that comes up a fair bit. But before we do that, like with our hyperbolas, it's a really good idea to understand some rules about square roots. And we know a little bit about square roots because we've dealt with them a fair bit in the past. So what's the square root of 0? Is that the smallest value that a square root can ever equal? Yes, it is. 0 is the smallest value that a square root will ever equal. The reason is because if we square root a negative, it's not possible in this subject. What happens in maths, specialist math? It comes in imaginary numbers just because regular numbers aren't quite fun enough. We need imaginary ones too. The range, it goes from 0 to infinity. Now that is of a baseline y equals square root x. Cool? If I transform it, flip it and do other things, then that will change. But if our baseline y equals square root x, our range, it can equal 0, but it goes all the way up to infinity. Happy with that? It does get there slowly, but it still can go on hypothetically to infinity. The domain is the same, 0 to infinity. Happy with that? Really important that we understand and remember that square rooting a negative is not a possibility. It comes up over and over again. So we've got our general form. Y equals x minus h plus k. What do you think A does? Dilates it. Slash, it can reflect it, obviously, we're aware of that. I should have done that yesterday. What does H do? Left and right. What does K do? Up and down. Where do I find my vertex? It occurs at HK. How nice that all of these functions do something at the point HK. Sweet. Why does that happen? Well, because when the thing inside here, when x equals h, what does the thing inside there? What's h minus h? 0. So that's why this always keeps happening. What? Because h minus h is 0, so when x equals h, whatever we're dealing with, whether it's a hyperbola, whether it's a square root, whether it's a turning point, it equals 0. When this equals 0, the smallest that can be is k. Happy with that? Very, very good. Do we need any more instruction on that? Any questions, or it's right? General shape is that wonky donkey where that is our vertex and that goes on forever. Cool? Awesome. Rip in.